Hello and welcome to April 20th, Monday, blah blah blah. Finals review too. I think we started finals review last week on Friday, kind of, with the project that was given. You have a ton of work to do, so I don't want to spend too much time lecturing today. You should be working on your video. You should work on the My AP that is due in 2 days for E&M. April 22nd, and then you also have the mechanics stuff that is due the following week, for a week from now. So quite some work, so definitely focus on getting your work done. We will lightly cover a few things for the next 4 days, at least for the first 4 units of mechanics. So let's start today off with the kinematics unit, the easiest. So a snooze fest. Kinematics. All right. Ooh, we have 0, 0. That's strange. Maybe the viewer thing is not working again. I don't know. Oh well. So quick notes, and then you go do your work. You might as well just watch all the AP1 stuff to review your mechanics. What is new? What was different about APC mechanics? Well, why does it say Q&A? Oh, because I don't want to lecture. Shredder was new, I guess. Nothing was new really. Well, the derivatives were new, I suppose. X being your displacement, or X as a function of technically X is the function of position. Where delta X would be your displacement, which is X with a vector hat. Deriving the range formula was new, I guess. Instead of deltas, we did like dx, dt. Now we have velocity as a function of time. We did dv, dt. So we get acceleration as a function of time. You can do dA, dt. Whoa, dA, dt. What is that? I don't know. You're a jerk. You're a jerk. Yeah, after jerk you get snap, crackle, and pop. Why are you calling me a jerk? So from here, you could, integrate and go backwards. So you are technically required to integrate. If you have acceleration is some constant value, like, I don't know, negative 9.8 or something. And so A as a function of time would be just a value, which means what? Well, it's a nice horizontal line at negative 9.8. If this were acceleration AT graph. And by taking the integral, so we have dA, dVA is equal to dV dt. Yeah, I need bounds, don't I? Is equal to some negative number. So we get dV is equal to, we'll call this A naught. A naught dt, integrate. We're integrating from 0 to v, and so we're integrating from 0 to t. Or let's not do bounds. No, that's definitely a dance move. Let's not do it with bounds. So what do we get? Well, we get v plus a naught is a constant, so not plus, equals a naught is a constant, so we get integral of dt, which is t, plus c. Right? You get a c term, the plus c term, when you do indefinite. And then you need an initial condition, like, for example, at v of 0, at 0 time, you get, why am I, go away calendar. V of 0 is equal to v0, v naught. Of course, at 0 time, we start at the initial velocity. And so when I plug in v of 0, we get a naught of 0 plus c, and this gives us the 0th value as c, which is v naught. And so this gives you v is equal to a naught t plus v naught. So v is equal to vo plus at. Oh, it's my key. Okay. Now Dawn looks kind of weird on our formula. Remember, it was VOT plus 1/2 AT squared, like this. But D is delta x, so know that as x final, which is x of t, minus x initial, x naught, is equal to VOT. So take the integral again, this is what you get. So x as a function of time is equal to x naught plus VOT plus 1/2 AT squared. Net external torque is applied to the system. Then it is not what it is. Range formula. What is the range formula? The range formula is VO squared times sine 2 theta sine of 2 theta divided by g. Not d, g, gravity. Beta? Well, r is a distance, so you can't be dividing by distance. So, and it's only good if your dy is 0. So only if dy is 0. So you launch something from the field, like kicking a football, punting a football, at some angle, hits a nice parabola, comes back to the ground. That's when you use the range formula. And of course the angles are symmetric, like so. Theta equals veta? No, it's theta. 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 There you go, Sword Hero. The ta. And range is actually dx. Here's your dx. And VO is not the component. VO is just the original, the actual hypotenuse, if you will. It is not the y component or the x component. That's the whole velocity squared times sine of 2 theta over g. And for fun, you can go ahead and derive it by setting up a Voivodjet, where VO is Voi is VO sine theta, Vy is negative VO sine theta. Remember, you come back with the same intensity, with the same magnitude. Okay, and your acceleration in the y-axis is negative g. Dy is 0, and you can solve for time. And once you do that, time is the same in both axes. So in the x-axis, dx vxt. Time is time. Vx is VO cosine theta. And dx is the range. So solve for r. And that should be pretty simple, straightforward. You get to use the double angle formula. So you might have to remember one of the trig identities. What else did we do? We did relative velocity. That was kind of huge. The dog and the cat, if you remember. Oh yeah. Here, let's see. Here's a classic. This is actually straight from AP1, but maybe you can do it with unit vectors. Let's say this was the classic boat question, if you remember. Let's say you get on a cruise ship and you start sailing, and you start going this way. Okay, so you're on a ship and you're going this way at some velocity v, 1, at some angle theta 1 here. Right. Unfortunately, your parents ended up on a different boat. Right. They are going the other way at some v2 with theta 2. Uh-oh. Yeah, so you are going v1, your parents are going v2, going the other way. Now, relative to you, they got on the wrong boat, right? But relative to them, you messed up. Ved, stop playing Minecraft. So question: if you are on this boat and you look through the window, so here's your boat. Oh no, it has 3 little thingamabobbers. Looks like the Titanic. Rip. So if you're on this boat and you look through those, boats usually have those circular shaped windows, right? Whereas planes have, airplanes have these weird oval shaped. Airplanes have like an oval shape. Usually the boat ones are much more circular. So question, as you're looking out through this window, here you are. Let's see if we can do this. There you are. Can you see it? Oh, look, it's you. As you're looking through the window at your parents, who are like on this boat. Okay, relative to you, what is their velocity? What is their velocity? So what is v? If I were to write this, the notation is v1, velocity of v1 slash v2. When you write this is a velocity 1 relative to velocity 2. And the slash is the relative part. Velocity 1 relative, rel, to velocity 2. How does this function work? Well, it's very simple. It's just a subtraction. Recall that if you had two people kind of walking, let's say at 5 meters per second, 5 meters towards each other, okay, you can say that velocity of A relative to B. Okay. So what is A's velocity if B is the observer? Okay, even though B is walking to the left, A is coming towards it, right? Towards it at double the speed, 10 meters per second. So notice as a vector, if this were V, B is actually moving at negative V, right? These are vectors. So what we did was we subtracted. So what we did was we did vector A minus vector B. So that's what the relative is. VA relative to B would be VA minus VB. Right? So this would give us a velocity of A, which is 5, minus the velocity of B is negative 5. And this gives us 10 meters per second. Relative to B, A is moving 10 to the right. If I did VBA, this would be velocity of B minus velocity of A, which would give us negative 5 minus 5, which is negative 10. Relative to B, velocity of B relative to A. So relative to A, B is moving to the left 10 meters per second. Okay, so what is their velocity relative to you? So what we're doing is v2 relative to 1. Oops, I should write v2 relative to v1. Oh, that's too big. Their velocity relative to you. So if you are the observer, okay, what do you see? What you see is that they are moving away from you. They're moving away from you at this angle and at that rate. So it's essentially the difference of these 2D vectors. Yeah. You can of course use law of cosines and then just get rid of it, be done with it, or break it down into smaller and smaller right triangles, right? You can break this down into a right triangle. You can break, let's use green into a right triangle. And then you can break down even the blue one into a right triangle. Let's see. Okay, and what we want to find is the hypotenuse of the blue one. The width of this blue triangle, so here's our blue. You can't really see. Let's use a darker blue. So what we're doing is finding this hypotenuse. The width of the blue triangle would be v1x plus v2x, right? And how tall is it? Well, it's the difference in the two heights, so v2 minus v1, v2y minus v1y. And then you can use Pythagorean to find the hypotenuse. So here is V. V1x plus V2x squared plus V2y minus V1y squared. Okay, relative velocities, you can do it with accelerating, non-accelerating frames, or you can do relative accelerations as well. Recall the, excuse me, the elevator problem with a bolt that is falling. A classic. Right. So the elevator is accelerating upwards, and the bolt is free falling downwards. It's almost like the bolt is accelerating even faster. The actual acceleration, or I should say, the apparent acceleration would be equal to a plus g, right? This is actually the acceleration of the bolt relative to the floor. The floor is now accelerating upwards at positive a, and you're subtracting the negative g, and therefore it adds up. All right. What else we got? Dynamics is where it really gets heavy. Kinematics is very light, and it's pretty much unlikely to be on the AP test unless it's some graph stuff. Linearizing curves, I guess, could be on the test. Or it could be a design. Marble in a cup extreme. What is marble in a cup extreme? Oh, with Kakarot? Let's see, what could be marble in a cup extreme? Here we go. Here's a loop-de-loop with a ramp at the end, and a cup that is strategically placed. Oops, I did this wrong. So here's our ramp, angle theta, and from the tip of the ramp we have strategically placed I'll call it dx, not r, so it's not confusing. Remember, r is only usable when dy is 0. So this cup is placed on the ground like this. So imagine like a golf hole. So this is like miniature golfing or something, but miniature marble in a cup extreme. Okay, question: how high up do I need to start so that we can not only negotiate this loop-de-loop of radius r, but also have I mean, we have to change 2 variables at least for this type of setup. This theta has to be adjustable, or d has to be adjustable. So such that as it launches off with whatever velocity after going up, let's see, h prime up, can it land in the cup? So there you have it. Launches and lands at same height h, right? Well, no, we have h prime. H prime is our ramp, but the cup is level with the bottom of the loop-de-loop and level with the bottom of the ramp. So imagine the cup being a hole in like a golf course. Ah, well, based on certain variables, no, based on certain variables, right? There is some play here. If you're a designer, yeah, it does. Okay, the answer is yes, it does. If you're a designer, okay, you have to strategically place all this stuff, right? Because if you let's say you have a very short distance d, then of course you don't need as much velocity, and it'll just parabolically go into the cup. However, if you don't have enough velocity, then you may not have enough energy to negotiate this loop. So now there's a kind of a tug of war between having enough energy to negotiate the loop, and then the velocity determining how far you're going to go. So based on this design, your constraint is the loop, the minimum energy required to negotiate the loop. V min is your constraint. Because if you don't reach V min to negotiate the loop, then you can never even get to the ramp in the first place. Once you determine what the V min is, this will determine what your exit velocity is. In this case, this VO, we'll call this VO, leaving at angle theta. V min determines VO. And once you determine what VO is based on your angle, this will determine D. Oops. This is actually an energy question. I should have left it for the energy review. But yeah. Anyway, the things to note from kinematics, at least, is that D cannot be solved by using the range formula. So if you look at the range, you'll see that it's only up to where it returns to H prime. So this part is R, your range formula. But D is an extra bit. And that extra bit is the amount that you're going to travel in the x-axis while going down h prime height. Well, the question is, which one is the variable that you can manipulate? That is the question. And so based on the constraints, you arrive to the conclusion that D has to be variable and or theta. H prime, if you change H prime, yes. If you can change H prime, so H prime, theta, and D need to be a variable in order for this to work. H is an R though. What? What R? A little r? Yeah, H is not R. Remember, you have to go higher. So let's even talk about the minimum velocity. Yeah, we went off track today, but that's all right. Minimum velocity required to spin around. Well, that's straight from AP1. You definitely have to go more than the height here. Let's see. How do I find V min? Well, V min is root gur, right? V min equals square root gur. And so if I start from here, we start from pure peg, and here we would have peg 2 and KE. So we would set the height, so peg minus peg 2 has to equal KE. And so the height difference is, so mg times the height difference. The height difference is h where you're starting from minus the diameter 2r must equal 1/2 m times velocity squared, which is root gur squared. Okay, m's go away. Since you square it, the square root goes away. There's g on both sides. The g's go away. So you have h minus 2r is equal to 1/2 r. All right, and then go ahead and add 2 r's to both sides. H is equal to 5. That's r. 2.5. 2.5. All right. Yeah, if kinematics is on a test, it would be definitely some sort of graph question, maybe relative velocity if you're lucky, but I highly doubt it. I have a feeling it's going to be some sort of rotational dynamics or type problem, and then some energy momentum problem. You have to design a lab somehow, or compare, contrast, and then explain reasoning type Tipper style questions, really. Yeah. All right. Go do your work, do your video, and do your my AP work. Thanks for tuning in. I'll see you next time.